Imagine a world without electricity, no lights, no computers, no internet, no communication. Now imagine the invisible force that powers it all, the force that makes magnets pull, lightning strike, and your phone connect to a satellite millions of kilometers away. That force is electromagnetism, one of nature's four fundamental forces and the backbone of modern civilization. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll dive into electromagnetism and Maxwell's equations, the elegant laws that unify electricity, magnetism, and light into a single, beautiful theory. You can watch the entire physics playlist by clicking the link below in the description. This topic marks the beginning of our new section, Classical to Modern Transition, Control, Fields and Motion, and continues our whiteboard animation series, designed to make complex science simple, visual, and unforgettable. The birth of electromagnetism. In the early 1800s, scientists studied electricity and magnetism as separate phenomena. Then, a simple experiment changed everything. In 1820, Hans Christian Ørsted discovered that an electric current could deflect a compass needle, proving that electricity and magnetism are deeply connected. Soon after, Michael Faraday found that moving a magnet could create an electric current. This was the birth of electromagnetic induction, the principle behind electric generators and transformers, the very heart of our power grids today. But it was James Clerk Maxwell who brought all of this together. In the 1860s, he formulated a set of four equations that unified electricity, magnetism, and light into a single framework, a discovery that changed physics forever. Maxwell's four equations, the language of light. Maxwell's equations describe how electric and magnetic fields interact and move through space. Gauss's law for electricity, electric charges produce electric fields. Gauss's law for magnetism, there are no magnetic monopoles, magnetic field lines always form loops. Faraday's law of induction, changing magnetic fields create electric fields. Ampère-Maxwell law, electric currents and changing electric fields produce magnetic fields. Together, these four elegant equations predict that electric and magnetic fields can travel through space as waves, electromagnetic waves. And when Maxwell calculated their speed, he found something astonishing: they travel at the speed of light. That's when he realized something profound: light itself is an electromagnetic wave. The unified field of light and energy. Maxwell's discovery meant that all forms of light, visible light, radio waves, microwaves, X-rays, and gamma rays, are just different frequencies of electromagnetic waves. This realization gave birth to the electromagnetic spectrum, a continuous range of waves that powers nearly every modern technology. Radio and television signals. Wi-Fi and mobile communication. Medical imaging like X-rays and MRI. Solar energy and laser technology. Every photo you take, every message you send, and every video you stream rides on the invisible waves described by Maxwell's equations. Electromagnetism in the modern and AI era. Today, electromagnetism isn't just the foundation of classical physics, it's also key to the future of technology. In AI-powered electromagnetic modeling, deep learning systems are now being trained to predict how electromagnetic fields behave inside complex materials and devices, from antennas and microchips to self-driving car sensors. These models help scientists design more efficient circuits, improve 5G networks, and even simulate the electromagnetic fields in human tissue for medical research. In short, electromagnetism has entered the age of artificial intelligence, where classical physics meets computational power. The invisible architecture of the universe. Electromagnetism shapes not only our technology but also our natural world. It governs how atoms bond, how light interacts with matter, and even how we see colors. From the flicker of lightning in a storm to the heartbeat of your smartphone, Maxwell's equations describe it all. They show us that the universe is an ocean of vibrating fields, an invisible web of energy connecting everything. This is the Learning Studio, and this was our episode on electromagnetism and Maxwell's equations. If you enjoyed exploring how invisible forces shape our visible world, make sure to subscribe, like, and check out the physics playlist linked below. In our next episode, we'll move into the world of classical mechanics and chaos theory, where motion, order, and unpredictability collide to form the patterns of nature itself. Because in physics, every equation is more than math, it's a story of how the universe speaks.